Alright, so I'm going to actually type some stuff. So we're going to put vectors and be written in using different notation. We will use column form. So you only have to know column form for your vectors, and then whenever you go into diploma, you will have to be able to write vectors in different ways. So a column vector has an x component and a y component. Excuse me. And your vector form looks like the following. So your x component goes on top, your y component goes on the bottom. So the x component tell you part2 Now this is in how many dimensions are we working in here? We're just looking at x and y. 2 dimensions, okay? Now we will only be working in 2 dimensions for MIT. Next year you'll be working in 3. And in 3 dimensions it would be x, y, and z, okay? And it doesn't really change very much. It's the same principle, except your column notation would look like that, okay? So that would be for your 3 dimensions, and this one is only for 2 dimensions, okay? But like I said, we'll not be doing 3 dimensions, but it's no more difficult. With difficulty. You have to be very good at visualizing things. No. No, there's other software that you can use. There's a piece of software called Autograph, which is really good. Okay, so our next, we'll have a little title, Writing Vectors. Because again, there's multiple ways that you can actually write vectors. Oh, it's a terrible straight line. Sorry? It says 2D, 2 dimensions, and if it's like this, it's in 3 dimensions. Okay, so writing vectors. Now there's different ways, and we'll just kind of go through. So, first way. Okay. This is the first way that we can write a vector, okay? So A to B, Okay, so capital A, capital B with an arrow telling us the direction that we're going. Okay, now A to B is a vector representing the translation from A to B. I'll move it down to about here. Is that okay? So for example, let's say the vector A to B is represented by 3, 2. And let's just put in an axis. My x-axis, my y-axis. Right, so the vector A to B this is how the vector is represented, okay, in column notation, 3, 2, okay? Now, it doesn't tell us, it tells us where to start. So what is the point we are starting at? A, right, we're starting at A. It doesn't give us the specific point of where A is, okay? So I can, let's say we want to put A here, okay? And it's saying that we're going how far in the x direction? 3, so we're going 1, 2, 3. And we're going how far in the y direction? 1, 2. So that is going to be B. Come on. Okay, so 3 in the x, 2 in the y. So this vector between these 2 points, use a different color. Represents our A to B. Now it's important to realize it doesn't tell you where to start, okay? So I could draw it down here if I want. I move 3 in the x, 1, 2, 3, 1, 2, up. What can you tell me about these two vectors? They're parallel and they are, yeah, they're exactly the same. And I need, whenever you're drawing vectors, you must, okay, because vectors always have to have direction. So I need to know whether I'm going from A to B or B to A. So to show that I'm going from A to B, I have to put on a little arrow. Okay. Easy enough so far? Okay, answer this question for me. Write down column vector of B to A. If A to B is 3, 2, what is B to A? Samara? What did you put? Right. Okay, so if I'm starting at B and I want to go get the A, if I go -2, so that's that direction. Okay, now remember the top one is always the X one. So how far do I have to go over? Okay, -3, and then I have to go right down to, which is -2. Okay, so this is where you need to be careful. Okay, the vectors is vector AB the same as BA? No. Okay, they're not always equal. Okay, not equal because they have different directions. Okay, they're going in different directions. What is the relationship here between A to B and B to A? Even easier than that. A to B is equal to what in terms of B to A? Negative B to A, okay? And that's always the case, because you're just going in the opposite direction. Now, magnitude, I'll come back to magnitude, but just to briefly discuss it, Marco said it is the size, okay? Or the length of this line. What can you tell me about the magnitude of A to B and B to A, do you think? It's exactly the same length. Okay, so the magnitude is the same, but they have different directions. So on your diagram as well, actually, if we just draw B to A, it's going to be, so if I put B in here, so it's going to go across 3, down 2. How does your diagram change? You're drawing B to A. Yeah, the arrow just goes the opposite direction. So this is, yeah, you can draw anywhere because we haven't been told where it starts, okay? The most confusing thing about vectors is there's a lot of new notation. But they're actually pretty fun to work out once you kind of get going with them. How far can I scroll down? Yes? No? All right, some more new stuff. Position vectors. Right, a position vector always starts or begins at the origin. Call that with a large O. Is it okay? Do you need more? You okay? Can I go down to there? Okay, so I want you to draw for me. Have a go at what's wrong, Lily? Practice some of these things. Alright, so O to A, we're starting where? Starting at the origin, starting at 0. We're going across 1 and then up 4. Yep, so we're going across 1 and up 4. So O to A is going to look like that. Everybody happy enough with that? So I'll label it. O to A, boom, boom. And all right, O to B is going across 5 and up 2. So O to B is going to finish up here. So I can draw that in. So label it O to B. And this is going in that direction, okay? So you have to have the arrowheads on here, okay? It's really important because if you don't know what direction you're going in. Is that okay with everyone? Right, to get from A to B, so we're starting at A and we are now going to B. So if I draw in O to B, let's use a different color. So starting at A, we are going to B. So it's going to look like that. I also need to put on an arrow because we're starting at A, we're going to B. Okay, is everybody okay with that? So we're starting at A, we're going to B. Now we have to write down what this vector is. Now, because I've drawn it, I can easily see what it is. How can I work out what it is, Marco?
We draw point A to point B.
Yeah. So A to B, so I'm going to move 1, 2, 3, 4 in the X. And how many in the Y? Down -2. Which one? This one and this one? Not quite, because we want to put this one in terms of a formula. Okay?
I'm just curious, this page be available anywhere? Like picture this page anywhere?
It'll be on YouTube.
Alright, yeah.
Okay. Right. So, in order to write A to B in terms of OA and OB, looking at this. Okay. Now, the way that we've just worked this out, 4, -2, we actually looked at it. We counted across 4. Okay. But the way that we want to start thinking about it going forward is you're starting at A. This is why I quite like these, because you're looking for the roadmap. Okay. You're going from A to B. To go from A to B, I have to go where first? If I want to get from this point to this point, and I can only travel along the vectors that I've got drawn, where do I have to go? If I want to go from A to B, how can I get there? Well, O to A is going from here to here. I need to go from A to O. Lely, are you watching? Okay, if I want to get from this point to this point, I need to go A to O first. And then where do I need to go once I'm here? I need to go to O to B. Is everybody with me? Now, if you haven't written that, that's fine. What's A to O the same as? If I'm going from A to O. What's A to O the same as? What do I notice about? It's not the same as OA. Yeah, I'm going in the opposite direction of O to A. So how can I write this in terms of O to A? Yeah, minus O to A. Yep, because I'm going in the opposite direction. And then to tidy it up a little bit, I'll just put O to B first. Subtract O to A. Now this kind of rule is so important, okay? It gets used loads. Sorry?
I didn't know you could figure it out that way. I just used it.
Yep, that's fine, okay? This is the kind of way that we want to start to think about it, alright? You're traveling along the vectors, okay? To get from this point to this point, I need to go bang, down here, and then up the way, yep. I'm going negative O to A, yep. Because I'm going in opposite direction, and then I'm going O to B. And this will work. If you've got the position vectors of any two vectors, and you have to work out, say, A to B, this is how you go about doing it, okay? Let me just quickly... Say again? No, you can't write it backwards, Aaron. Always has to go left or right, okay? And this helps if you don't have a diagram, okay? So if O to P is equal to 3, 2, and O to Q is equal to negative 1, 4, find E to Q. Okay, because it's not all the time that you'll want to draw these things out, okay? So have a go at this one, please. I'll start you off. P to Q equals alright, so negative 1, 4 is cross negative 1 up 4, and it's starting at O. Okay, so we all okay that's my vector O to Q. And I want P to Q, so it's going to be the line in between them. Okay, so I can see that I'm going back 1, 2, 3, 4. So negative 4, and then I'm moving up 2 places. Okay? Or if I'm starting at P, I'm having to go to O and then up to Q. Okay? Starting at P, then going to O, then going to Q, which is why I am subtracting this OP, okay? Because I'm going in a negative direction. Alright? Yes? No? Like literally 5 minutes, but let's have a look at it's going to be page 57 in the extended book. I've got some copies here, and for you, Ari, have a go at this at home.